Hi everyone. I'm Gaoyuan, a researcher at Yale. Together with Mark, who is a professor at Yale, we are building SafeHbar to enable secure access to quantum computing. So, quantum computing has the potential to transform lives, to transform science and industries, but there's one major barrier, which is privacy. So quantum computing is cloud native, meaning you have to send your sensitive data to the quantum hardware vendors, something that many regulated industries cannot allow. Current approach to for a secure quantum solution generally fall into two categories. The first one is classical adaptations to build those hybrid security frameworks, but because the underlying mechanism was never built for quantum systems, they suffer under great overhead. The second one is quantum native, called blind quantum computing. But they were designed for a zero knowledge privacy guarantee at the cost of very high resource consumption. As a result, they are also impractical for large-scale data analysis and data access. We identified a middle ground, which we call quantum native confidential computing, a practical quantum native privacy solution for protection of individual level data while enabling scalable, efficient data access and analysis. Let me introduce SafeHbar. We utilize quantum properties to develop privatized quantum representations and the corresponding privacy-preserving quantum analysis protocols to enable secure quantum deployment without exposing end users' raw data to quantum hardware. Quantum operations on those privatized states, their results closely approximate what you will see on the original data while protecting individual level information from being reconstructed or inferred. This is how it looks like in practice. Pharmaceutical companies, banks, or researchers partner with quantum hardware vendors to carry out advanced analysis. But company policies, IP concerns, and regulatory constraints prevent them from sharing their raw data with the quantum hardware. But integrating SafeHbar's privacy layer would allow the quantum hardware to carry out those operations on those sensitive data without revealing the underlying raw data. Our business model is B2B, centered around embedding SafeHbar's privacy layer into quantum as a service providers' APIs. We will generate revenue through two main streams. The first one is we will establish annual licensing partnerships with major quantum hardware vendors and generating a recurring licensing revenue. As a second, we will also offer specialized client-specific privacy solutions tailored to end users' needs. And we will offer that as a part of the quantum as a service provider's service offering and capture value through a royalty of the service contract. We see a huge market opportunity here driven by the fact that privacy is a gating factor for quantum adoption. So far, we have proven our core technology through extensive simulations. And as the next step, we would like to continue engaging with quantum as a service provider, quantum hardware providers, validate our prototype on their target platforms, and also defining a clear regulatory certification pathway while broadening our IP portfolio to cover additional quantum privacy primitives. Thank you.
Could you touch on how you differ from other privacy competitors in the space?
Yeah, so the main part is that so for data access and data analysis, if you think of biomedical or those kind of area, those data analysis settings, some level of population information are intrinsically public. So you don't necessarily need a zero knowledge proof, zero knowledge, privacy guarantee in those settings. So we allow for a very small amount of information to be leaked, which is, for instance, the population level information, in exchange for much lower overhead.
Who's working with you on this project? What's your team to actually deploy this?
So from the scientific part is my PI, Mark Gerstein, with me, and a few other lab members in Mark Gerstein's lab here at Yale. At the same time, we have advisors from different areas, including pharma companies, including banks, and also I have mentors who support me through this business development. Yeah.
I guess, what would make you and your team most suitable to solve this challenge?
So we combine expertise from different areas. We know the data we are dealing with. We know the issue that people owning those data are facing. At the same time, we also have quantum capabilities to, find the right solution to solve those problems. So we really understand the issue with the data, the problem with the data, the sensitivity, while also being able to understand enough quantum computing to find the right solution to tackle those problems.
Now, just a quick one from me. You skipped through it fast, but the market opportunity that you see would be interesting to know. And I guess more importantly, how much is relevant to the timing, and how much can you, how much are you in control of that timing versus everyone else in the chain?
Yeah, I think, I guess, of course, our company, our solution will only be useful if a lot of people are using quantum computers. So I guess with the scaling of quantum computers usage in general, we will be able to scale up. And so we compare what is the current market size for AI and what is the current market size for confidential computing. And we see that's around 10%, meaning a privacy solution for quantum systems probably would also be around 10% of the entire quantum computing market size. So if the quantum computer are going to scale up, we will be able to capture 10% of the entire market size.
Question around modality. Is this, I assume this is agnostic to the type of modality of the qubit modality. And is there one that you're partnering up with first and leaning into, or is it truly agnostic?
You mean the data modality, the data?
Yeah, the data, yeah.
Yeah, so we try to, the core technology is independent of data modality, but continuing forward, we do want to utilize what is special about different data types to design even better trade-offs between utility and privacy.
Very quickly, the core problem that you're trying to solve, right? So that the trust between me running my data on the quantum computers or the quantum computing company vendor that's up there doesn't see my data, or is it just trying to secure my data in the journey over to that?
I guess multiple. So first of all, of course, there's no reason why you should trust a quantum hardware vendor. So we do want to help you build that trust to the quantum hardware vendor. But at the same time, there's really regulatory constraints that would not allow you to send any of your data in the raw form outside your organization. So in my field, biomedical data science, there's a very strict rule of you are, no matter if you trust them or not, you're just not allowed to. So also that's what we see as a gating factor, and we do want to help people to bridge that gating factor so that biomedical data science and finance or defense can fully take advantage of this breakthrough technology. So it's really for regulated fields to fully take advantage of this breakthrough technology of quantum computing.
Right. Thank you very much, SafeHbar.